No, it's let me see. Here. Okay. So let me show you guys here. Actually, okay. So you want to know how to translate the address in a multi-level,
Yes.
right? Paging. So basically, okay. Let's come back here first. Okay. Because I didn't get to talk about all these. Okay, so let's stay here. So you look at here. So this is this is a two-level setup, right?
Yeah.
This is a two-level setup. So how do you you guys already get the basic idea for what I talked about two-level,
Basic.
right?
Yeah.
So these are so basically this is essentially how many bits. Okay, say when I talk about this, how many bits here for the offset? This is a 32-bit. So I have a 2 to the 12 number of bits for the offset. Okay. So
I'm sorry, how much for the offset? 2 to the
yeah, how many entries for each page? The page
2 to the
size.
12. Okay, 2 to
Yeah,
the 12.
the page
Right,
size.
right.
Like for each page.
Right,
Okay.
2 to the-
So and then that would leave like 2 to the how many 2 to what number for the number of entries in the page table. Okay. I let me. You guys all got this? I can.
More or less.
Yeah. You want to take a picture of this, or I can erase
You
this?
can erase.
You can use
You
it.
can
I
erase.
just-
Okay.
yeah,
All right.
I can just ask you.
Okay. So, yeah, I actually skipped one an important part actually. So, all right, let's go from the beginning. So we have 2 to the 30. All right, so we have 2 to the 32. So this is, let's say, this is the 32-bit system. So we have these many possibilities for unique addresses,
Yeah.
right?
Right.
So these many. So this is essentially what? This is 4 gig, okay? 4 gig? Yeah. So then we set up this paging. We set up page size as 4K. That's what? 4 KB. That's 2 to the 12, right? So that many bytes, right? Okay. So if we only set up one level of page table, one level, okay? Let's do that. One level page table. How many entries are there in this one level page table? How many entries?
How many entries?
Yeah.
212?
Okay. This is the page size for each. Remember, we were talking about this is the chunk of the memory space. Okay, we divide these into chunks with equal size, right? Right. So each one of these is one page. Okay. The size of this is what?
2 to the 12, 4 KB.
Right, 4 KB, right? Right? So let's say this is the physical, like a memory address, right? A virtual memory address space.
So do you have 2 to the 20?
Yes. So let's say this is a page table. How many entries you need there for all the pages to identify all the pages with this page size? You got the idea? No? Okay. So this is the address space size, right?
Yeah.
4 KB, 4 GB, 2 to the 32, right? And this is each page is this big.
Yeah.
How many pages you can have?
Divide?
Yeah.
Yeah.
How many? Oh, you know what? I should do this. So number of page. No, let's do one at a time. So number of pages equals to what? Equals to what?
232 divided to 12.
Right. That's correct, right?
Yeah. 210
20.
or 220.
That means in this page table, I need how many entries here in this page table?
2 to the 20.
2 to the 20. Yes.
So
Right.
if you have a 64-bit system, then
Yeah.
do you
that's
still
it.
use a 2 to the 12-bit?
Yeah, some people they still use this size. Yeah, so that's then you can imagine.
So then you have 2 to the 52.
Yes, so that's
Interesting, okay.
just so huge, right? I remember, it's to have this. This is just 2 to the 20 different entries in the page table.
Mm.
How much memory you need for this table? You guys have thought about that?
Mm,
So we talk about like the page table entry. Each page table and each page table entry is you can set up whatever you want, right?
Yeah.
It dependent on how many, like it actually normally you for 32-bit system for each page table entry you have you use 32-bit for each for each entry here.
Got it.
okay.
All right. So, what determines this? What determines the size of each entry? You guys know?
There's how many lines? How many levels?
How many addresses you want
Right,
to
yeah.
get to, right? Yeah.
Mhm.
So like yeah again, like well I talk about the present valid bit.
Right.
Remember?
If it's a 1, it's valid.
Right. I also talk about a number of other bits, right, in the page table entry, but those bits are for management purpose, like for other purposes. Let's say just for now, for other purposes, right? And the rest bits, they're used for what? They're
For
used
here?
for
For PT?
no. The rest of bits, they're used for how many different possibilities? Like how many different possibilities of your what?
Pages? Or no?
Right.
Okay.
Pages. Okay.
Right.
Yeah.
So yes, so essentially this we talk about it's just how many pages you have, right? So like essentially, so okay, but you have 32-bit. You can like well normally they set up each page table entry the same size as the system word size.
Okay.
Normally that, but you don't need that many, right? For this case. How many you need here? Excluding all the special bits I just talked about, how many you need here for each entry? How many, at least, how many bits you need here?
32.
32?
It's
So
most
the-
32, right?
Okay, so this page table, this is like, okay. This page table for what? For storing what? What information?
The physical, or the physical frame, right?
No,
No?
no, this is, the page table is what? Page table is for for mapping, right?
Oh, yeah.
Yeah.
Yeah. It's
Right.
many.
But it maps from the virtual
Virtual to
address
physical.
Physical, right.
Right. So each entry here is what? Each page table entry is about what? Corresponds to each virtual page or physical page, right?
The virtual page.
The virtual page.
Yeah.
Well, this is the translate both, right? So we talk about. Okay. So I know this is a. Okay. So I know. Okay. So normally you start from 0. I talk about you use the virtual page number
Mhm.
as the index. You set up this as an array,
Right.
and at a particular position, you store what? You store the frame page
the
number.
physical frame.
The physical frame, right? So each entry is what? Each entry is for a page, right?
A page or a frame?
A page or frame.
Oh, are you
Right.
using them synonymous?
Well,
change
I
later.
mean, is it, well, I mean, it has both, right?
That's a virtual page, but the contents of it is the actual
Yeah,
physical
frame.
right? Okay.
Yeah. But what I'm talking about is how many bits, if you want to represent like these many, how many bits you need? 20, right? At least you need 20, right? I know this
Why
is
only 20?
right. At least, right? At least you need 20. Because you have 2 to the 20 different possibilities here,
Oh,
Okay.
okay.
right? You have, okay. How many, okay, so here you want to map all these, assume your physical space also has this much memory, okay? So here you have 2 to the 20th number of virtual pages, right?
Mm-hmm.
You want to map them all.
Right.
How many entries you need here? 2 to the 20,
Right.
right?
So, but why were you
so
saying
how
you
many-
need at least 20?
Well, you need to have at least 20 bits to differentiate between pages.
Okay.
right?
I got you.
Is that like
Yes.
okay?
Yes.
Maybe I didn't ask the correct question. So you need okay. So these are okay. I'm sorry.
No,
Okay.
that's fine.
It's-
Yeah.
Okay, so 2 to the 20th number of pages. So this table needs to store that many different number of pages.
Mm-hmm.
So you tell me each entry has to have how many bits at least? 20 bits, right? So
20
okay,
bits.
I know this is okay. So it's like this. Let's say normally you put 32 bit. The 32 bits is more than that. So let's say 32 bits here. So you have
At least it's 20.
you have 20 bits. Yeah, at least 20 bits. Oh, okay. See ya. So and the rest you can use for whatever you want. Okay.
Okay.
So the 20 bits. So let's say each entry you have 32 bits there, but at least 20 bits are used for what? For remembering all these pages. Is this part clear?
Mm-hmm.
Yeah.
Okay. So that's for one level. Yeah.
Okay.
One level. Okay. So you could set up this page for this exam for the simplest case is like you could set up this as for each entry you only have 20 bits. Right? You could do that, you know. But in the assignment it was 32, right? Okay. So basically so that means with this page size, right? This is the space, the total space. With this page size for each page, you can have that many pages, right? That many virtual pages, right? So 2 to the 20, yeah, right? That's for one level.
Mm-hmm.
All right. So if we want to go to 2 level, how are we going to do it? I say for like, so let's get rid of this. You got this part? This is the
Yeah.
whole memory space.
Mhm.
You divide this whole memory space into chunks, right? Then each chunk will have, each block has a 4 KB, right? That means you need to have these many pages, right, for the whole memory space,
Mhm.
right? Okay. So this is a one level. Yeah. What about 2 level? You can do whatever you want actually on 2 level. You can do whatever you want. You can split. You can do like so many possibilities, right? You can do the first level 8-bit and then second level 12.
Is it advantageous to have your second page be larger? Wouldn't it be the other way around?
Yeah, that's a
Because
very
you
good.
said you're not going to get to the.
That's a very good question. Actually, normally, yes. Normally, you set up, well, the first normally for this, if you have 20 bits, right, for the number of pages, normally they do 1010. Okay, so the advantage is that, okay, so if you have more entries in the first level, and you may have, well, sometimes people make this the second large, the second level large, because if like so here, like say we have this this setup, okay, 1010, okay, so this means you have how many entries in the first level?
32.
Huh?
The entry, right?
Okay, so this is two-level mapping for the page table.
Okay.
So if I have first level with 10 bits, right? You have like 2 to the 20, right? Second level with another 10 bits. The first level will have 2 to the 10, right? The second level,
2 to the 10.
2 to the 10, right? For each entry in the first level, it has, right? It has 1 page, right? So the second would be this, right? You have the second entry in the first level will correspond to another 2 to the 10, right? Right? And so on and so forth, right? So if you make this big, make a second level big, sometimes it could be advantages, like say you make this as 2 to the 16, right? Right. The key here for multi-level is that maybe maybe on the second level you only need 1 page as good enough for your process. You don't have to create all other pages.
Oh, okay.
Okay. Right. So that's the flexibility. But for one level, you only get 1 choice. You have to have this many.
Okay.
Right?
Got it.
Because of the, you have to differentiate between each page number. First level, you have these many. Second level, you have 2 level. If you have 2 level, you can have just, you can have the first level page set up with only the first 2 entries set up for mapping to 2 pages on the second level. And the rest, you can set the valid bit to 0, 0 for the rest, because you don't use that. Okay, so this drastically save a lot of space. So you say your program only needs 2 pages from the second level. So that's it. So sometimes if you make this big, you can just satisfy your program needs, and you don't have to set up all other tables, right? So that's advantage. Okay. So but nonetheless, so this provides a great flexibility, right? So if we do this kind of setup, so first level 10 bits, second level another 10 bits, right? So so overall you have what, 10, right? So this is the total. You have to, if you want to get that many pages, right? Right. So with 2 levels, what's the minimum? What's the minimum pages you can have with 2 levels set up?
It's 2 times 2, 18. Like
Okay.
that.
So with 1 level, you have to have that many entries,
Oh,
right?
yeah.
2 level, you need to have 1 entry here, right?
Right.
Or 1 times 2, 20.
Right.
1
So
times 2 to the 10. Or
Yeah.
in this situation,
yes. So in this situation,
okay.
you can set up all other pages.
To be
You have 1
0.
page is
Right.
is valid, right? So you have what? You have 1 page corresponding to another 2 to the 10. So essentially, well, even you set all these as 0, you still need to have at least 1 table, right?
Oh, okay.
The first level has to be this, right? 2 to the 10, right? The second level, you can only have 1 there. At least 1 there, right? So it would be 2 to the 10 plus 2 to the 10. This is the smallest you can have with the 2 level. Yeah, that's okay. Hi. So, right? So versus this is like what, 1 million entries. This is what?
2048.
8K kilobytes, right? No, not even that. So 2 to the 10 this is, oh yeah, this is actually, so each entry is 32 bit, right? You have 2 to the 20 is 1 million, right? Times what? 4
Sorry.
bytes.
4 bytes.
So this one has this at least 4 megabytes for one table here. What about this one? Right, this is what 2 to the 10th is what? It's 1K.
Yeah.
Times 4.
4.
Each entry is 4 bytes, right? So this is a 4K
Okay.
plus
Plus
4K.
4K.
This is
8K.
8K. So with the 2-level setup, you only need you can set up this way with minimum only 8K, right? And the reason why normally this is the case for like 10 bits for each, you guys can see that. Where do you like? You know, I didn't get time. You know, I really shouldn't rush. Like all these, I should have talked. So for each page table, you also need to save each page table. Where? Where? You also need to save, like how do you, like these are page table, right? This is a page table
Right.
for mapping. Where do we need to save it?
In the kernel? Or no?
Sure, in the kernel, sure, yeah. But we also need to save each page table to memory, right?
Oh, okay.
Right? So itself, the page table itself also needs to be in the memory, right? So, so that's why, like, I mean, normally for 32-bit system, if you have 4 KB for the page size, right? So this page table, each page table can fit into one page. You guys see that? So, 4 KB. Each table here, you can put each page table into one page. I know it's a lot of numbers. So, but anyway, so this is for you guys to know. Okay, so if you have each entry with 32-bit, right? And this actually you can set up. You can. Oh, sorry. Okay. Thank you. So anyway, so here, right? Again, each table entry for one level is 32-bit, right? And you only need to have you only need 20 bits for these many different pages, right? So when you set up this, when you set up the like excluding, don't worry about these. When you set up 2-level, and you for the first level you need 10 bits, second level you need another 10 bits, right? Of course, in your programming, you still in your programming you always deal with this integer. Integer is always 4 bytes, actually. So that's still 32-bit. So every time, so that means you will use an integer to remember, like each entry for the first level. You only need 10 bits. So so you only need the lowest 10 bits in an integer to remember each entry. Okay. So this is a 2-level setup. Okay. So, so your program should be flexible. You can specify, how many levels. So if you set up 2 levels, you can set up a first level with 8-bit, second level with 12. Or if you set up 3 pages, you can set up like I did in the class. In the class I did 888. I have 24 bits for the page table. But you could do, essentially you have 32-bit. You can do whatever. As long as you have some bits at the lowest end for the page, right? So you can set up a very small page. Let's say if you set up a very small page as 2 to the 4. If you set up your page as 16 bytes, that means the total bits for your page for representing your virtual pages would be what? If this is the page size, if this is the page size, what's the total number? What's the total number for the pages? Doing more exercises.
It's
If you
divide.
have this as the page size,
Okay.
what is page size?
It's a size.
The,
It's,
each frame, right?
yeah.
How many bytes in each frame or each virtual page? Each virtual memory page? So here, like normally the page size is 4 KB. I can use a very small page size. So with this very small page size, how many entries in one level of page table?
You have divided it.
You use 2 to the 32 divided by
Yeah.
2 to the 4.
2 to the
The
4,
four.
right?
It's a 2 to the 28.
The 2 to the 28, right? You need that many, right? So whatever you can divide this among how many levels you want. You can divide this with what? 4 levels. Let's say, for example, 4 levels with each level is 7 bits, right? You can do that, yeah?
Yeah.
Or you can divide this with, like, 3 levels, right? With 10, 10, 8, right? Whatever the way, as long as the sum of them equals to 28. Are you like, sort of getting the idea?
Yeah. I think it'll take some more time for me to like sleep in. But yeah,
Yeah,
Kinda
I know.
it's like-
It definitely
Yeah.
takes